everyone, I'm Dr. Padmavati Tungaturte from TeachConnect. I'm a quality education specialist. CBSE Class 10 board examination are not a barrier to anybody. All the students can definitely undergo this training of competency-based learning and they can solve the question. The questions can be tamed. Let us first understand how the sample question paper is made, which is released by the board. This is the second part of subject science, which we have already analyzed the first part of it. This is a second video. First, watch that video wherein there are multiple choice questions analyzed, and this one will be for the section B and C. Let me share the screen. Let us go to CBSE academic.nic.in. Here we have sample question paper, science with subject code 086. Part A, we completed. Now this is for the part B. Then part B and part C we shall do here. Question number 27 to 26, these are very short answer questions. Question number A, section A, these are most appropriate options. That means there are 3 distractors and 1 correct answer. You have to challenge yourself why you have chosen that answer. The teachers are supposed to train the students regarding this aspect of reading the question correctly, that is to read, to understand, and also to comprehend. Now we can see that dilute HCl, this is the 21st question, dilute HCl is added to zinc granules. How will you prove that chemical change has taken place here? Support your response with 2 arguments. There are a few important words which are given here. How will you prove that chemical change has taken place? That means a visible evidence must be there. The chemical reactions will take place because dilute HCl and zinc granules have come into contact. That's how proof has to be given that there is a reaction which has undergone. If the student is not able to provide the proof, that is the visible evidence, then the child may not be scoring marks for this. And how many arguments are supposed to be given? 2 arguments are supposed to be given. We have drawn this question paper from the sample question papers which are released by the CBSE board. And dilute HCl has enough of water. Zinc granules are in contact with HCl. Then of course zinc chloride and hydrogen gas is evolved. That is the chemistry part of it. That is the content part of it. Now what's the skill which is asked here? There is an evidence for that the reaction has occurred. Now what's the evidence? The evidence is there are bubbles coming out to show that there is reaction which is happening. Then in order to prove that the bubbles are hydrogen gas, then definitely we can test it with a moist litmus paper, or we can test it with a burning splinter bringing near the gas so that it burns out with a pop sound. And another response, that is the first argument, is there are bubbles. The second argument and the evidence which we are providing is zinc, which is a shiny metal, will change its color. Zinc chloride is formed, isn't it? Now it's no more zinc because this is an instantaneous reaction. That's how the student should be able to provide 2 arguments. And if you want to write down that temperature has increased because this is an exothermic reaction, temperature change is observed. These are the things which the student is supposed to write. Therefore, the teacher must train the student to observe the intricacies of the question. Now we are only analyzing the physics and the chemistry part of it. Therefore, we'll jump to question number 24. That is, the refractive indices of the 3 media are given below. There are 3 media given and 3 different refractive indices. Of course, Let the student take time to understand the table. What are the components given in the table? That is medium and the refractive index. There are three different media given. That means we are not concerned as to what are the media. That is, the refractive indexes are different. 1.6, 1.8, 1.5. Now the child's understanding comes into picture. 1.5 is less denser, 1.6 is grade 2 denser, and 1.8 is the thickest. This is the information the child has understood. Now, let the student take time to read the question. A ray of light is traveling from A to B, and another ray is traveling from B to C. What did the student learn in the classroom? He has only learned that when the light is moving from rarer medium, the ray of light is moving from the rarer medium to a denser medium. The ray of light travels towards the normal. This is a fact which the student remembers. Now, how are we going into the applying level of it? That is, A to B, it is moving from a rarer medium to a denser medium. Definitely the ray should bend towards the normal. And now from B to C, the light ray is moving again from a denser to a rarer medium. That means the light ray will move away from the normal. This is how, based on the concept which is learnt in the classroom, the question can be answered here. Only one concept is learnt in the classroom, that the light ray moving from a rarer medium to denser medium will move towards the normal. That's all. In which case the speed of light increase? In which of the two cases the refracted ray bends towards the normal? It is in the first case. In which case that the speed of light increase in the second medium? When it is moving from denser medium to rarer medium, because obviously the material is thin enough. Give reasons for your answer. This is a very interesting question. A piece of wire of resistance R is cut into 3 equal parts. These parts are then connected in parallel. If the equivalent resistance of this parallel combination is R1, what is the value of ratio R1 is to R? One wire is taken, it is cut into 3 pieces. That means the resistance becomes 1/3. When it is parallel connection, we know that 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, wherein 3 different resistances are given. Here all the 3 resistances are the same. Therefore, 1 by R by 3, that becomes 3 by R. 3 by R plus 3 by R plus 3 by R. That becomes 9 by R. 9 by R will be equal to 1 by R1. When 9 by R is equal to 1 by R1, they are asking you the ratio. Therefore, 1 by R1 is equal to 9 by R. That is the ratio of R1 is to R will be 1 by 9. This is how it justifies the answer over here. Now here we have understood that refer to the image below and state how the magnetic field pattern indicates regions where the magnetic field is stronger outside the magnet. What happens to the magnetic field when the current is reversed? There are 2 parts for this question. Refer to the image below. With respect to this image only, we are supposed to give the answer. How the magnetic field pattern indicates regions where the magnetic field is stronger outside. Outside this bar magnet, where is the strength? How is the strength? Outside this bar magnet, how is the strength? Where the lines are closer, the strength of the magnet is higher. If the strength of the magnet is lower, indicates that there is a lot of space between these region. The magnetic field strength diminishes as it moves away from the magnet, right? What happens to the magnetic field when the current in the circuit is reversed? We know where is the north pole, where is the South Pole. They move from the North Pole to the South Pole. That is a fact which we have learned. Now, if the current is reversed, the direction of the magnetic field also will reverse. This we have learned. Here, looking at the diagram, that is what is competency-based education, wherein we focus on what is being learned here. Now, the next question is from the section C. 27th question. The given reaction shows one of the processes to extract the metals like iron and manganese. Manganese dioxide, which is in the solid form, and aluminium, which is in the solid form, they both react with each other and tremendous amount of heat is liberated. That's why it is an exothermic reaction. It is not only an exothermic reaction, it is a thermate reaction which allows lot of heat and it is useful for welding purposes. This is a fact which we have learned in the classroom. Here, this question is clubbed up with oxidation and reduction. Identify the substance oxidized and reduced in the above reaction. When oxygen is lost, it is reduction. When oxygen is gained, that is oxidation. Manganese dioxide is losing oxygen, then manganese dioxide is undergoing reduction. Aluminium is oxidized to aluminium oxide. This is what they are asking here. That means the student must know that concept, that when oxygen is lost, it is reduction. When oxygen is gained, it is oxidation. This is just a small concept which is taught by the teacher during the classroom session. The child is able to apply and analyze whatever is happening in the classroom. That's fine. We need not worry if it is 2 board exams or 1 board exam or no board exams, or whether there is competency-based learning. Everything must be per se with respect to the question here. Now we have 28th question. Element M with electronic configuration 2, 8, 3. That means the third shell is not filled yet and it is ready for reaction. Combine separately with chloride ion and sulfate. It is very specifically given that it is combined separately. Metal combines with chloride ion and metal combines with sulfate ion. Write the chemical formula. We know that writing a chemical formula is taught in the classroom just to interchange the ions. M with 3 plus, Cl with minus. They interchange the valencies and write down as M1 and Cl is 3. This is very, very simple, provided the student can understand and not get confused to analyze what is M. No need of analyzing what is M. It is not required. We are only supposed to understand, and our focus should lay on 3 positive and 1 negative. Here again, 3 positive with 2 negative ion, which is 2 minus. Therefore, again, interchange of valencies. M is 2 and sulfate ion is 3. M2, SO4 taken thrice. This is how we write the chemical formula. Let us check with the answer. Yes, it is given here. M2, SO4 taken thrice. Then, how will the electrical conductivity of the predict with suitable reason the nature of bond formed by element M in general? Element M has 3 electrons extra. It wants to donate its electron. That's an electrovalent bond. There is no covalent bond formed here because M can easily give away its 3 electrons. That's how ionic bond forms here in general. Or the student can also attempt another question. A reddish brown metal X. A reddish brown metal. Look at the syllabus, whatever we have. Here syllabus comes into picture. That's copper. Reddish brown metal, whatever we have is copper. And don't get confused with the rust, and that is a compound. Here it is a metal. Therefore, it is for sure a copper metal. When heated in air, gives a black compound. Of course, it is copper oxide. When heated in the presence of hydrogen gas, hydrogen, oxygen goes away and gives X back, the copper back. X is refined by the process of electrolysis. This refined form of X is used in electrical wiring. Copper is used in electrical wiring. The student can analyze the answer. If it doesn't strike to the student that it is copper, then immediately when the student reads the answer until the end, he can say that X is used in electrical wiring. Then it's copper wire, because we already read in the resistance and electricity chapter also that copper can be used for electrical wiring. It undergoes oxidation first, giving Y, and then reduction to give X back. Identify X and Y and draw a well-labeled diagram to represent the process of refining. This is process of refining is a memory question, remember and understand, whereas oxidation reduction is an application question. Hope it's very clear how to frame the question and answers, and also to train the students on these competency-based questions. 31st question, explain why the, before that we shall go to the answer what is given. Yeah, this is what is electrolysis process. And this is the answer what the student is expected to write for this question 28. 31. Explain why the refractive index of any material with respect to air is always greater than 1. This the student does know this answer. It is only an explanation, remember and understand. The refractive index of any material is higher than 1 because we take air as a norm. That's the base, wherein we can compare with other elements. We always write this formula, speed of light in air by speed of light in the medium. We compare it with the speed of light with air. For it is some benchmark should be there. It is chosen to be air. That's how that we can compare it with air. In the figure below, a light ray travels from air into the semicircular plastic block. This is a plastic block. Observe the diagram. No hurry to write the answer. This is the normal. The light ray is incident from here. This is plastic block and this is the normal, and it is incident at 40 degrees. The light ray is going. Oh, wonderful. In the figure below, light ray travels from air into the semicircular plastic block. Give a reason why the ray does not deviate at the semicircular boundary of the plastic block. If the density of the plastic block is equal to the density of air, it doesn't deviate, because it doesn't make any sense that the item or the element is available. Semicircular boundary of the plastic block, it doesn't deviate. Or if the light ray is passing through the normal, then also it doesn't deviate. But here in this case, the density of the plastic block is equal to the density of air. That's the reason it doesn't deviate over here. See, it is given a straight line. Therefore, the student must be very well aware of the fact that if there is a density change, then only the light bends. Earlier in the first question, we have seen that light bend, but here there is no density change. That's why light doesn't bend. Complete the ray diagram of the above scenario when the light ray comes out of the plastic block from the top flat end. How does it come out? It just goes straight, right? Let us see the answer. This is again 40 degrees over here. Because angle of incidence is equal to angle of refraction, it's again 40 degrees given over here. This angle is again 40 degrees. Okay, now let us see. State the law that explains the heating effect. Explain is simple memory question. of current with respect to measurable properties in an electric circuit. What do you measure in electric circuit? Measurable properties, you measure current, you can measure resistance, you can measure the temperature change. This is measurable property. Therefore, connected to Joule's law. Therefore, if the student is able to understand and read the question correctly, that heating effect and measurable properties in electric circuit, then the job is done. Therefore, it is given that Joule's law has to be explained and the fact has to be written. The formula can be written. H is equal to I square RT. This is the answer C, because we know this is the explanation for the Joule's law. Yeah. Then, list the factors on which the resistance of a conductor depends on. Resistance of a conductor, when we have read resistance laws, we know that resistance is directly proportional to length of the conductor. Resistance is inversely related to the area of cross-section. This is what, and the resistance is dependent on the temperature of a conductor. That means one specific temperature, one specific resistance works, and the nature of material. These, because the question, here it is written any two should fetch full marks, but I advise you all to ask the students to write down the complete answer, because the knowledge and the thoroughness will increase. Then, therefore, if the student is able to understand how the electric current variables work on, then the child will be able to write the answer. Question number 33, Ananya responded to the question, why do electrical appliances with metallic bodies are connected to the mains through a 3-pin plug? The child knows that the third pin is important, but here it is reasoning out. He has to analyze and apply what's happening. Whereas an electric bulb can be connected with a 2-pin plug. Electric current, bulb, all the electricity pass must only glow and convert into light. But here, when a person is using an electrical appliance, a low resistance wire is connected, because that's a good conductor, is connected so easily. The extra current suddenly, if it flows, it has to flow inside the earth. That is what we call it earthing. Therefore, she wrote 3-pin connections reduce heating of connecting wires. They reduce the heating of connecting wires. Probably Ananya has not understood the concept. That is not the right answer, because we have to see that the low resistance wire is connected in order to see that the extra current passes into the earth. What's the function of fuse in a domestic current? If there is no fuse, then the whole of your bulbs, everything will get fused off. When electric current passes, then very small amount of current, extra current pass, the fuse wire melts. When the fuse wire melts, the electricity stops flowing. This acts as a very big savior for electrical equipment. That's the function of fuse in a domestic circuit. This completes section C. And in this section, we have covered B and C. That's a wonderful experience for me also to analyze the question and answers. It's a lovely thing. If the students are able to draw great benefit from the analysis of the question paper science code 086, then the children will have competency-based learning in place. That is, how to read the question is very important than being in a hurry to write the answer. Thanks for watching my video. I like analyzing the sample question papers because I would love to see what the other side of the paper is. I would really love to analyze it. I want to read the examiner's mind. I want to read the paper setter's mind. That's how these papers, this will add value to your way of teaching. Thanks for watching my video. Share it to as many people as possible. as many teachers as possible, as many students as possible, because students will learn from this explanation. This is a joint effort by everybody, the teachers, the parents, me, and the school. That's how we can see that the students come up with flying colors. Thank you so much. By the way, don't forget to subscribe to my channel. Thank you.